Hello YouTube viewers, hope you're all doing good and welcome to this video. In my previous video I talked about Helm, the client-side component, and the Tiller, the server-side component. It's basically getting started with Helm, how you can install the Helm and the Tiller and some basic commands. So as promised in my previous video, so this video is going to be installing an application using Helm. So I've chosen Jenkins because I also wanted to do a video on Jenkins, so I thought I would combine these two videos into one. So in this video, I'm going to show you how to install the continuous integration, continuous deployment CI/CD pipeline tool Jenkins in your Kubernetes cluster using Helm. So we can also deploy Jenkins in Kubernetes manually, but it will make a lot easier. It will make our life a lot easier if you follow Helm. It's just one single command, Helm install Jenkins. That will install Jenkins, and it's going to deploy loads of resources in your Kubernetes cluster. So I'll walk you through this video and how we can install Jenkins, how we can run a job, and so on. So for that, as usual, I'm going to bring up my cluster, which is a clean cluster from scratch, and I'm going to use Vagrant to provision my VirtualBox machines. CD to play, I'm going to git clone my Kubernetes repository. CD to Kubernetes and then to Vagrant provisioning and do Vagrant up. Right, it's going to take around 9 minutes, and meanwhile, I'll talk about the structure. I've got some notes here. Right. What we're going to do here is we are going to use Helm to install Jenkins. So for Jenkins, we need persistent storage. I've also done a video on the NFS dynamic provisioning. So if you haven't done that, I would suggest you to watch that video because that's a prerequisite. Because when you do Helm install Jenkins, it's going to create persistent volume claim. So there needs to be some way of dynamic storage provisioning. If you haven't got that dynamic storage provisioning, you need to create the persistent volume yourself. If you go and watch my video, the title should be dynamic provisioning, dynamic NFS provisioning in your Kubernetes cluster. So I've explained how you can use a pod inside your cluster to provide the dynamic provisioning. So it's basically this one. So you can use your existing NFS server, and for me, in my case, the NFS server, the whole Kubernetes cluster, everything is running on my workstation. So I've set up NFS server and I've exported srv NFS Kube data directory, and once the cluster comes up, I will deploy this NFS provisioner pod, which will have this volume mounted inside the container under /persistent volumes. So that bit is the dynamic NFS provisioning bit. So once that's done, we can use Helm to install Jenkins, and Jenkins will create persistent volume claims, which will trigger the provisioning of persistent volume. So you will all see that when I do that in action. Okay, so we are deploying Jenkins, and the Jenkins installation using Helm automatically provisions the Kubernetes plugin for Jenkins. So along with Kubernetes plugin, it also installs a couple other plugins. So using Kubernetes plugin, we can use the cluster itself to launch slave pods. For example, you've got the Jenkins pod, and from within the pod, if you create a job, you can make the job run on the slave pods. So the slave pods will get dynamically created, so there won't be any pods, any slave pods, and once you create a job, Jenkins job, it will launch a new slave pod depending on your job's configuration, whether it's a parallel one or sequential one. It's going to dynamically create a pod, run the job, once the job completes, it's going to destroy the pod. So yeah, everything is within the cluster. And in my cluster, I've got one master node and two worker nodes. Okay, so that's the theory. So to do this, you got to you have to watch two of my previous videos to be able to follow this video. Because in the previous video, getting started with Helm and Tiller, I've explained how to install Helm and Tiller, so that's required for this demo. And for dynamic NFS provisioning, there's again a video for that. Please watch those two videos before watching this video. If you're just watching, that's fine, but if you want to follow along with the exact same setup that I've got, you have to watch those two videos to get the setup right. Okay, enough talking. Let's see the status of our cluster. Okay, it's still initializing the cluster. I think it's going to take another 5 minutes. I'm going to pause the video here and come back when the clusters have been provisioned. Alright, the cluster has been provisioned. I'm going to copy the kube config file from kmaster. Make dir.kube sap. Okay, that's copied. If I do kubectl cluster info, kubectl version -- short 113.2, kubectl get nodes, all of them are in the ready status. Okay, so the first thing I'm going to do is I've already exported srv nfs directory. Sudo export fs -v, srv nfs kube data has been exported. So I need to provision this NFS provisioner pod, as I explained in my dynamic NFS provisioning video. I'm going to go one directory above into YAML's directory NFS provisioner. I've got 3 YAML files to deploy, and I'm going to edit the deployment.yaml to update the NFS server IP address. And my IP address is 1095.65.213. Can update that here as well as here. Okay, and I'm gonna deploy that. kubectl create -f rbag.yaml -f class.yaml -f deployment.yaml. Okay, so that's all done. So we have dynamic provisioning now. Whenever we create persistent volume claims, the persistent volume should get created automatically. Okay, so now let's go ahead and install the Tiller component. So since this is a brand new cluster, I haven't got Tiller installed. kubectl -n kube system get pods. So I haven't got Tiller installed, but I've got Helm installed. So I'm going to create the service account for Tiller. I'm going to create a cluster role binding for Tiller to have a cluster admin role. Okay, so now I can deploy Tiller onto my cluster. Helm init -- service account Tiller. And if I do this command again, so there is the Tiller and the container is getting created. Container is getting created. It should be ready in a minute. Okay, the status is running, but still it's not ready. Okay, cool. The Tiller is ready now. Right. Let's install Jenkins. So how would you install Jenkins? Normally, Helm install. If you search for Jenkins, Helm search Jenkins. So there is a Jenkins application from the stable repository. Helm install stable Jenkins. That's all that's required, but we're not going to do that way. We are going to customize some options in the Jenkins configuration. So this application comes with a set of configurations, but we need to update few configurations. So I just need to download the config file first. For that, Helm inspect values stable Jenkins. I'm gonna pipe that to redirect that to a temporary file, jenkins.values. And if I edit that file, so these are the basic values. The name of the Jenkins master is Jenkins master. The image we are going to pull is from Jenkins Docker Hub and the Jenkins image. Image tag is LTS, image pull policy, and there's lots and lots of options. So I'm going to edit this file, and I'm going to use this file for overriding the default options. Either you can edit this file completely and you can use this file for installing Jenkins, or you can remove whatever you don't want, because all the default settings it's going to use from the application, and you can just include what's exactly needed. So I'm going to delete all these lines to have it clear. Master name of the Jenkins master is going to be Jenkins master. That's okay. I'm not going to change this option, so let's delete it because it's going to use the default one. I don't want these lines. Component image pool secret admin user, so I'm going to delete all these lines. I'm going to set the admin password here. Admin, and the password is also admin. I'm not going to change the admin user, so let's delete that. Resources, requests are fine, but limits, my worker nodes are just 1 CPU and 1 gig memory, so I'm going to change this to 500 millicore and memory to be 1024. So since I haven't changed the requests, I'm going to delete them. Environment, container environment, use pod security, these are all fine. So let me delete all these. Pod security, service port, service type. So until here, I'm going to delete it. Service type, I'm going to change this to node port so that we can access it by accessing any of the worker nodes. Service annotations, deployment labels, service labels, that's all okay. Okay. Load balancer range, extra ports. There should be a node port option. Where is node port? If I search for node port, yep, here it is, node port. I'm going to set this to 32323, and I don't want all these lines. I'm gonna delete all these entries because I don't want them. I don't need all these installed plugins. So these are all the plugins that gets installed as part of Jenkins installation. Kubernetes plugin, credentials binding, Git plugin, and so on. So I'm gonna delete. I don't want init scripts, config map, overwriting. I'm gonna leave all those to defaults. Ingress, I'm not interested in ingress. Okay, let me delete up to here. Agent. Agent is enabled, so that's the slave agent. And the image for the slave agent is going to be JNLP slave image tag. Component resources are all fine. Pod retention never. Volume, node secret. Okay, so those are all looking good. I'm not going to change anything. So let me delete all these. Persistence enabled. This is where we need to do some bit of tweaking. Storage class. As I'm using dynamic provisioning, my storage class is kubectl get storage. Managed NFS storage. Managed NFS storage. Enabled true. I'm going to delete all these. Enabled is true. I haven't changed it, so let's delete that. volumes, size 8 gig. Let me change that to 5 gig. Let's delete these lines. Volumes, mount are all okay. We can delete rest of the entries. Network policy. Okay. RBAC. Service account. If you don't edit this, if you don't install RBAC, you'll have problems when it comes to launching the slave pods. So you need some permissions for the service account to create pods. So we need to install RBAC. Let's change that to true. I'm going to delete everything until here. Backup is not enabled, so I'm going to delete all the backup configurations. Okay, that's all. Okay, so that's our customized values file. I've only included the options that we've changed. So admin password was commented out. I've enabled that and changed it to admin. Resources, I've changed the limits from the defaults to 500 millicore and 1 gig RAM. I've changed the service type from load balancer to node port. I've added the option node port to 32323. Persistence, I enabled the storage class to my custom storage class and changed the size from 8 gig to 5 gig. And RBAC, the default false to true. So these are all the changes. So this file, I've removed everything except the changes that I've made. I'm going to save that file. So now it's time to install Jenkins. Let's watch kubectl get all. So at the moment, we haven't got anything except this deployment, replica, set, and pod. These are all for the dynamic NFS provisioner. So this bit here. Now let's go ahead and install the Helm chart. Helm install stable Jenkins minus values temp Jenkins dot values minus name my Jenkins. So if you don't give this minus name option, it's going to give you a random name. Okay. If you want to install this in a specific namespace, you can add option minus namespace Jenkins or so on. Even if you don't have the Jenkins namespace, it will create the Jenkins namespace for you. But in this demo, I'm just going to deploy this Jenkins application in the default namespace. Okay, I'm going to hit install. I'm going to hit enter. Okay, and you can see the deployment my Jenkins was created and the replica set got created and the pod is also getting created. It's running the init container at the moment. It has created a couple of services. One is the my Jenkins service on the node port 32323. So that's how we are going to access the Jenkins dashboard. And there is a Jenkins agent listening inside the cluster. Okay, so if I scroll above what it did, so it says status is deployed resource. So you can basically get an idea of what resource it deployed. So as you can see here, it deployed a resource service account called my Jenkins. It has defined a cluster role binding, and it has defined a couple of servers, Jenkins agent service and the Jenkins service. So this is the service that it created so that we can access the Jenkins dashboard. It has created a deployment. It has created a pod. It has created a secret, a couple of config maps, and it has created a persistent volume claim. And down here, you've got some nodes saying how you want to access the node. The dashboard. Get your admin user password by running. Basically, we know the password because we overridden the admin password. So we know the password, which is admin. So we don't have to do that step. And this one here is saying how to access the Jenkins dashboard. So once we access the Jenkins dashboard, we need to do a little configuration on the Jenkins to enable it to create slave pods, right? So as you can see, this pod is still under initialization phase. I think it's downloading the Jenkins container image. It's a bit big image, so it's gonna take a while to download the container image, and eventually the status will change to running. But meanwhile, I wanted to show you kubectl get pvc. You can see this persistent volume claim was created for this Jenkins application when we did the Helm install Jenkins. And the status is already bound. It's bound to the persistent volume, this one. So we've created the 5 gig persistent volume with read write once under the storage class managed NFS storage. So if I show you kubectl get pv persistent volume, so that's the persistent volume that got created, that got provisioned dynamically. We didn't create the persistent volume um, because if you see Helm status, my Jenkins, pipe that to less, you can see what resources it deployed, the Helm chart. It didn't deploy any of the persistent volume, so it created the service, deployment, pod, secret, config map, persistent volume claim, but not persistent volume. So we've the persistent volume got provisioned dynamically using this NFS provisioner. It's mounted this SRV NFS Kube data, and if I take a look at SRV NFS Kube data, so that's the directory for the persistent volume for Jenkins. Okay, it says Jenkins is running and it's not ready yet, so let's give it a couple more minutes. And once the status changes to ready, we can access the Jenkins dashboard. And there is one step that we need to do to make Jenkins, to give Jenkins access to creating the slave pods. Okay, what you can do meanwhile is you can look at the Jenkins log file, kubectl logs for the pod my Jenkins. So that's the Jenkins log running from user share Jenkins jenkins.war file, and you can see. Okay, so what I'm going to do is I'm going to watch this log file. Alright, the Jenkins instance is ready. You can see here, and you can see Jenkins is fully up and running. So now we can access the dashboard. I'm going to keep this log open so that you can see when it comes to creating new slave pods, you can see what's going on in the Jenkins. Okay, so now I'm going to go to the browser and go to one of the worker nodes, kworker1 32323. Nope, it doesn't seem to be ready. Let's check that once again. kworker1 32323 32323. Okay, that should be ready. Okay, let's check the kworker2 kworker2 colon 32323. Okay, so I wanted to mention this. So the reason we are having difficulty accessing kworker1 is this Jenkins instance is running on kworker1, and we have set the limits. When you noticed temp jenkins.values, we set the limits to 1 gig, but the default was 2 gig. The kworker 1 and kworker 2 nodes, they both have just 1 gig memory allocated to them. So it can't allocate more than 1 gig. So that's why it's a bit struggling, but if you want, you can increase the memory to 2 gig on your worker nodes. Okay, so that's why it's a bit slow as well. Log file, we know the username admin and password is admin. Signing in. Okay, so before we do anything, I'm going to go to the credentials directory, Jenkins, global credentials. I'm going to add credentials, and the kind of credential I'm going to add is Kubernetes service account. Scope is global, that's okay, and click OK. And go back to Jenkins, manage Jenkins, configure system, and when you install Kubernetes plugin, you will see a section called cloud. So there we need to add this credential. Jenkins is very slow because of the memory limitation. So if you increase the memory on your worker nodes, it should be really fast. Since my vagrant provisioning script allocates 2 gig of memory for kmaster and 1 gig for each of the worker nodes, you can change that if you want before doing the vagrant up command. Okay, so if I scroll down, this is the cloud section, Kubernetes plugin. Name Kubernetes, Kubernetes URL, Kubernetes.default. That's okay, so that's the Kubernetes, that's the service, and that's the namespace, default namespace. That's okay, Kubernetes namespace is default. Credentials, this is where you need to add. Secret text. Add Jenkins. Okay, I think that should be enough. Just select the secret text and see if you can connect to it. But before that, I'll show you something else. So that's the Jenkins URL. My Jenkins is the service name, 8080 is the port number, and you can see the container specification, pod specification for the slave nodes. So when this Jenkins instance launches slave nodes, it's going to use this image, JNLP slave 3.271. That's the container template, and what's the home directory, workspace directory for your Jenkins nodes, and so on. Okay, let's test the connection. Testing, and back in the console log, you can see some activity. Connection test successful. That's the bit I wanted to see. Okay, save. So now what I'm going to do is I'm going to create a test job, demo job, a freestyle project. Click OK. It's taken a little while. Jenkins connection timeout cannot be less than or equal to 0. Don't worry about those. So back in here, watch kubectl get pods. So that's the Jenkins instance NFS client provisioner. When I create a job and trigger the build of that job, you're gonna see new pod appearing here, and run the job, and then the pod will get terminated after the job completes. Okay, build. I'm going to add a build step here, execute shell, echo, hi, this is from inside the container, hostname, sleep for 20 seconds, save. That's saved. Let's trigger this build now. So I've triggered the build, it's waiting for the executor, and back in here you should see some activity in the Jenkins log. So you can see here, started provisioning Kubernetes pod template from Kubernetes with one executor. So very soon you will see a pod getting created here. Okay, so that's the slave pod that got created automatically. So container creating at the moment. So again, it's going to download the Jenkins JNLP container image, which is going to take a couple of minutes because again, it's a huge image. And it says waiting for pod to be scheduled. So basically by default it waits for 10 minutes, 600 seconds. and this is the slave pod name, so it's getting created. And if I show you kubectl describe pod default, you can see now it's pulling the image. At the moment it's pulling the image Jenkins JNLP slave agent. Okay, and let's wait for it to complete. So once it completes, back in the Jenkins dashboard, you will see the job will be running. Okay, so that says the Jenkins pod is running now, and back in the dashboard, you should soon see that the job will get started. Waiting for agent to connect. So it waits for the agent to connect. So once it's connected, it will run the job on that node. I think it has connected. No, not yet. No, it's still trying to connect. Okay, so that's the Jenkins slave node. Yeah, so the slave has connected and it's running the job at the moment. So if you look in the job console output, it says building remotely on default G5K6L. So that's the Jenkins slave agent, slave node. Okay, so this is a simple job that echoes something, prints out the host name, and sleeps for 20 seconds. Okay, so that's the echo statement. Hi, this is from inside the container, and the host name is, just to make sure that the job is indeed running inside the container, I wanted to print out the host name, which is the host name of our pod, and it's now sleeping for 20 seconds. So let's wait for this job to complete. So once this job completes, you will see the pod getting terminated automatically, and you'll see that in the Jenkins log. Okay, so it says finished success, and back here it says terminated, and you can see the slave pod getting terminated, and it's gone. Cool, that's all I wanted to show you, and let's delete this Jenkins application. kubectl get all, there it is, and Helm status my Jenkins. We've got the Helm. If I do Helm list, so we've got my Jenkins revision 1. If you want, you can upgrade the Jenkins version. Helm upgrade my Jenkins if you have downloaded the latest chart. And if you want to roll back to a previous version, Helm rollback my Jenkins. If you just do Helm rollback my Jenkins, it will roll back to the previous version. But there's also an option to roll back to a specific version. Say for example, if you have done too many revisions, you can go back to a specific revision. Helm help revision, Helm help rollback, rollback flag, and that's the release. If you want to go for a specific revision, you can go to a specific revision. Okay, let's delete it. Helm delete my Jenkins -- purge. So if you do that, it will delete the persistent volume claim as well. And if you delete the persistent volume claim, it's going to delete the persistent volume as well. kubectl get pv, pvc. You can see the reclaim policy is set to delete for the persistent volume. So when I delete the application using Helm -- purge, that's deleted. These are all getting terminated. And if I do Helm status my Jenkins, because it's not there, Helm list, it's all gone. kubectl get pv, pvc, no resources found. So pvc, excuse me, PVC got deleted when we did the Helm delete command, and since PVC is deleted, the associated persistent volume also got deleted. And if I look at my exported NFS directory, there is nothing in there because that persistent volume got deleted. Cool. I think that's all I wanted to show you in this video. What we did in this video was used the NFS dynamic provisioning. We used Helm to install Jenkins, and inside Jenkins we used a custom values file to override the default values. We set the admin password. We changed the cluster IP from load balancer to node IP, node port. We set the node port to 32323. We've changed the persistent storage class and changed the size of the volume from 8 gig to 5 gig, and we installed RBAC. So those are the custom settings we want to override in the Jenkins application. And then we deployed using Helm install Jenkins, passing the values file. And once Jenkins is running, we logged into the Jenkins dashboard and added the service account credentials, and we created a sample job and ran the sample job, which created a slave pod, and the job completed, which deleted the slave pod. And finally we deleted the Jenkins Helm Jenkins application, and that deleted all the resources it deployed in our cluster, and the automatic persistent volume provision has also been deleted as part of deleting the persistent volume claim. Cool. That's a lot in this video, and I'm sure it worked out for you. And if you had any questions or any comments, or if you don't understand any concept here, or if you want to if something goes wrong, something went wrong following this video, just leave me a comment. I should be able to help you. Cool. And if you liked this video, I hope it was useful, and if you liked it, please share it with your friends. And if I had done something wrong, please let me know, because normally I follow the official documentation, practice it, understand it better, because I need to be able to answer to the viewers' questions. So I make sure that I understand it thoroughly and it works in my environment before doing a video on it. So if something is not quite right, or if you think something can be done better, just leave me a comment. I should be able to help you. And don't forget to subscribe to my channel. I've got a few more Kubernetes videos planned in the coming weeks. And thank you so much for your time watching this video, and I'll see you in my next video. Bye bye.